All right, so I'm going to welcome everybody to the February edition of our ISA Twin City chapter. February for us is going to be a tech talk. As mentioned in our last board meeting, we have members from Dunwoody's Autonomous Snowplow Competition, Autonomous Snowplow teams. They're here. They're going to do a presentation tonight. I told them it was a little bit informal, so there's a lot of pictures, there's a lot of video. What I hope our members of the ISA will do, they'll maybe ask questions or so on and so forth as we're going along, or feel free to stop us. For the students that are in here, just so you know, the ISA, the International Society for Automation, there's a number of sections, not just in the United States, but around the globe. And it's a tight-knit professional organization of people that work in instrumentation, automation, controls, SCADA, robotics, SCADA, HMI, all the type of stuff that you guys are studying, all the type of stuff that robotic snowplows need, right? Cybersecurity, computers, all of those. So if you're ever interested, Dunwoody has kind of a unwritten rule. Maybe it's a written rule. Dunwoody will pay for a student membership for any student that wants to be a member of the ISA. The goal being that when you graduate someday and you start making good money, that you might become a professional member like the folks in the room here. So I don't know if do we want to go around real quick and just introduce ourselves so they know who they're talking to? Wait till Tom's got a big bite of it.
Let's do it at the end.
Do it at the end? We can do that at the end. All right, so I'm going to bring up the PowerPoint slides here real quick. Give me a second. And Seth, can you see the slides?
Yep, slides look good.
Awesome, thank you, sir. And these are recordings, so this will show up on ISA's YouTube channel as well. So if you ever want to go back and watch it or anything, we'll be able to go back and watch it. So maybe I'll start with you guys introducing yourselves and what major you're in and maybe what drove you to become part of the snowplow team.
I'm Liam Ewing, and I am in the Automated Systems and Robotics program. It is my second semester at Dunwoody right now. As for why I decided to join the snowplow team, is honestly, I just went to the orientation and saw, I don't know if it was EJ, you were the one that talked about it.
Yep.
But I heard about it and thought that Autonomous Snowplow Competition, that seemed pretty cool, and I guess the rest is history.
I'm Alex Niles, also with Automated Systems and Robotics. I was in robotics in high school on the first robotics competitions, and I followed the path coming into snowplow. So.
Good evening, everyone. I'm Daniela Pimentel, currently majoring in computer engineering. The reason I ended up doing the joining the snowplow team and doing the snowplow competition. Computer engineering is like half electrical engineering, half computer science. I wanted to see how I could integrate both components into automation, and so far it's very interesting.
I'm only going to move this. These guys get online and stuff, get a little better sound and view of you guys here. So that's give them a little bit better sound. All right, so we'll start off with we got a short little video that you guys can watch here. I'm hoping the folks online can hear this too. So I'll hit play on this. This is not just for automated snowplow team, but I thought it was kind of cool to include here because it kind of incorporates all of our teams. So it goes quick. It's only a minute long. I'm gonna watch that twice. All right, I'll let you guys pick up from there. You guys just tell me when you want the next slide.
I don't know if this is true about previous years, but at least from my knowledge, this year we were a part of, I believe it was Fox 9 and Care 11. There was like a news segment about us. That's me right there. That's the snowplow that we brought. Oh, you're fine. That's the fiducial target. Basically, we went on for I think it was about like 5 or so minutes. We had a segment about us, and we just talked about basically what we're doing. What I'm doing to you guys right now is basically what we did. We just said this is the snowplow competition. This is what we do. I guess a part of it was also to try to get people to come to the competition as well, like to actually see it on the day. This was about a week before it began. Setting off the next slide there, EJ.
Our team members, Kit, who is the team lead for Snowplow, Snow Devil, actually took this photo with their personal camera.
Can you speak up,
Oh, for
please?
sure.
Yeah.
So this photograph was actually taken by one of the team leads, Kit, with their personal camera. So this is not the marketing team. This is one of the Dunwoody students. Did an excellent job.
Very cool picture.
Sure. So this is the course that we did this year. The vehicle would start in the garage zone here. And the idea is it would move out and remove these 12 squares of snow. From where there to anywhere on the sides here. There would be penalties for hitting an obstacle. They put one on the side, one in the field that you were supposed to actually drive around. And then also you're supposed to keep inside the course as well and avoid hitting the blue boundary. You had to make it out here into the course and then back basically. Here. That's basically it. It's just to plow the snow from those squares to the sides and then avoid the obstacle in general.
The interesting thing about the challenge is that we actually get 2 runs throughout the day. We get one in the morning and one in the afternoon. So say your first run didn't go so well, you get to make adjustments for the afternoon and likely improve. So one adjustment, can you talk about that little?
Yes. So on our first run of the day, the issues that we noticed is that on its way back, like as the snowplow was coming up here and turning back, it would dump a bunch of the snow right here. And so you get penalized for leaving snow in the course like that. So we added this little like guard to the side here. So the snow would, instead of leaking out the side here, would just pile up on this plow blade, basically. And we also made it go up and around, basically clear more of the snow. You are allowed to make adjustments like that. It depends on the order, but it's usually like more than a few hours. So we just were able to rig that up in a few hours, and it did work pretty well. So we're probably gonna start using that on all of the plows in the future.
That adjustment was actually a design that came from Laval in Canada. The adjustment came from Laval in Canada. Their team actually had one of those. I was like,
Laval, huh?
Mhm.
Wow.
And they did really well, so. This is just the Dunwoody team's makeup. The students, along with their respective majors. Ashley Souther, who is not here at the moment, she will join us in a few minutes. She is part of the automated systems and robotics. Liam, to my left, myself, Alex Niles, and the rest of the team that could not be here this evening.
So I am not pictured in that photo there,
I am there.
unfortunately. So I am on the ice hockey team. This year we placed second out of, I believe it was 8 or 9 teams, right, EJ? It was 8 teams. 8 teams?
Yep.
Yeah, so second place out of 8. As you can see here from this picture, our plow used a camera on top running Robo Realm to identify these fiducial targets that we placed around the course. And basically we'd have the robot drive towards it until in its camera, the target grew to a certain size, and then that's how it knew that it needed to turn around. Secondarily to this, the camera is also looking for the color of the cone I don't think you can see it in this picture, but there's an orange like traffic pylon cone that was like the thin, long cylindrical one, not the cone shaped one. Basically, if it saw that orange color at a close enough distance, it would then do like a secondary action of driving around it, basically. And that did work very well this year, as far as I could tell for an EJ here. This was the first robot to successfully, consistently avoid the obstacle. At least according to Dunwoody teams. Other teams in the past have done it, but compared to the rest of the Dunwoody teams in the past, this one was the first one to consistently avoid the obstacle. So, pretty proud of that.
No doubt. Yeah, well done. BZ.
This is me here lining up the placement of the fiducial target. There's one on this end, and then I'm looking at the other one on the other end of the field to try to get the placement of it correct. And then this is the final. This is after the robot did its did its thing. Basically, this is what the course looked like afterwards. As you can see, the obstacle orange one in the center there remains intact. So
It was a 97-point run out of 100 points. Come on up, Ashley. We got Ashley here now too, so now we got all 4 of our team members. So.
I think they're removing second target, but that up there was the other fiducial on either end of the field. So I would kind of go to this one and then down like that.
Was it cold out there, Liam? You look cold.
It was cold. Yeah, I was wearing like a blue ski mask the whole time. It was pretty chilly. We were not out there for that long though, so it was not too bad.
All right, Liam. So this is a video. You are welcome to narrate the video all you want. I'll hit play. It's gonna last. I don't know how long it lasts. About 2 or 3 minutes, probably. So I'll hit play, and then you can feel free to narrate.
So our guide starts up there, and it's turning from the first target here, and then I think it's right here. It gets stuck. Yes, right here, I believe. I think it lost traction or something. It was slipping in the ice. As you can see, it's not moving right now. It should be moving. In the moment, I was very concerned about this because it had not done this. This year, we were not able to test with much snow because it was not snowing.
Yeah.
Yeah. I think it was maybe like 1 or 2 days. So I was concerned about this happening, basically where it got stuck. However, it does recover. It's continuing to what I think is happening here is the target is what it's looking for is constantly being lost and then found again. So it's like moving back and forth because of the way I programmed it or something. Honestly, I don't really know. I've never seen it do this before. I've not been able to test for it, but it does. You see here now it's back and forth. So
Yeah.
it very easily like crashed into the blue boundary there. So it kind of squeezes by the yellow cone there on the side, and then it moves all the snow off to the front of it, and then it should turn around. Right, it will turn around once it sees the fiducial target there.
Liam, this is your second run, right?
Yes, this is the second run.
You can tell because if you look at the plow blade on the left-hand side, it's got that guard and it's catching all that snow.
Yeah, yeah.
Just making the second turn here. Has to be very careful with we have to be very careful with the fiducial target placement because if you place this target too far this way, the cone will end up blocking it inside of the camera. So that's kind of why I was very meticulous about that. And well, luckily during both of our runs, it did not need to perform like the special maneuver I added for it to try to find the target again if the cone does block it on one of its turns. So I'd say we did a good job in that department.
Did the sun or the glare of the sun?
No,
didn't
the
affect
sun. No,
vision?
oh, for the most, I think for all of our testing, like sun and weather conditions did not really affect the camera that much. I think it did affect it a few times, but it wasn't consistent with it. So I wasn't really able to test it that well, and it never happened like in enough times. I think the biggest issue with the sun is that it would make the cone such a different color that the camera couldn't see it anymore. But right here, these conditions are basically optimal. I don't think the camera doesn't really give you a good perspective of it. But it is about to turn around that cone right there. So the plow blade gets very close to it. And that's kind of intentionally, if you recall the image you saw before of the finished course, there is like this much room between the snow and cone. So it's a very, very precise maneuver that it makes right
Yeah,
here.
when Liam was programming this and he's like, well, I'm gonna come within an inch of it. I'm like, why? Why do you want to get so close to it?
Reason why is so that we don't like lose all that snow in the middle, because that's really the big drawback with avoiding the obstacle, is that if you do it, you do run the risk of either hitting the boundary or dumping a bunch of snow in that square that you can't get anymore, and that is deducted against you. So as you can see here, it made the first pass around the obstacle. It's now reacquired that fiducial target and is now back in line to continue. Third turn there.
EJ, we didn't test earlier. I'm hearing from Ryan that he's seeing, he's on the call, but not hearing anything.
He's not getting any sound.
Yes. And I said, there's no sound on the video of the snowplow competition,
No,
but you're not
this-
hearing Liam's presentation either, so he's responding now. Yeah. So I don't know what's going on with the owl and all that.
There, I don't know, probably not from where you're standing, but it does basically the same thing again. I do have to correct for the distance of the target, because on this one, the target it's looking for, the one that's behind the camera, is smaller in its screen, and it knows where it is on the course based on the size, like the size of the target. It tells it how far away it is. But that's not just as you walk towards something, it gets bigger quicker. Once you're really, really close to something, it'll get a lot big. But if you're really far away and walk away, it does not get that much larger. So there's you kind of have to correct for that.
I'm gonna real quick bounce out and see if I can get the sound working here. Give me 10 seconds here.
You're all right.
Seth, can you hear us?
Yep, I have voice, no problem. The slideshow is not making noise for me, but I do have voice without an issue.
But you could hear our voice the whole time?
Correct, yep.
Okay, sounds good. All right, I'm gonna go ahead and kind of go ahead there. Liam, then you can kind of talk it out there.
All right, so it's coming back towards on the first run, right about here, it would have turned back this way to go to that one. But in order to actually get all the snow, because as you see, if it would have turned, it's going to leave all of that just running in the course as it goes back into the garage. So I made it continue driving and make another loop, so that way this, like the catcher rail, is on the outside of its turn, like this. Instead of being on the inside of the turn, like it would have been right there.
You get awfully close to that yellow obstacle too.
It is almost okay.
So I think what's interesting about this is one of the most successful runs Dunwoody's ever seen at the competition.
I would just like to put out there, Liam did this with printed target and one camera. And he got
The team that got first place had like 12 different sensors on their guide, and those only did like slightly better in terms of the score. And honestly, I'd say it was likely luck. It was like 5 points more some way. I think it was either time difference or they just got slightly more snow than us. So it was a very, very close competition this year.
Your PDRs.
And the PD, I think no, I think higher. Yeah, they did have a higher preliminary design review score. That's the presentation that we do before the. It's like the checkpoint halfway through, basically.
Does this turn around when it parks too?
It does, but I stopped it because I didn't want to run any risks of it, like hitting anything or whatever. I wanted to lock in my perfect run where it was right now. But yes, it does. After it gets down, it spins around. It goes. But I don't think this video shows it. I just
Stopped it right there. Very, very nice. That's awesome.
And so this was not set up, I didn't go to this year's. So it wasn't set up in a graduated form where you have a semifinal.
There was no bracket. It was
No brackets.
each team competes 2 times. They take the highest of the competition score plus your presentation scores. Then just whoever has the highest score wins, basically.
And did you get enough judges?
Yeah, we always are looking for judges, but yeah, we had plenty of judges. Probably the biggest, from my standpoint, the trickiest thing these last 2 years has been snow.
Yeah.
We have to make snow every year. It's the goofiest thing you've ever seen. So you'd think in January, a snowplow competition would be safe. 2 years in a row, no snow.
In Minnesota.
In Minnesota.
Yeah.
Exactly right.
You had a nice little setup though for it.
Yeah. We bought snowmaking equipment now. So we have the ability to do that. We have cold, we just don't have snow. All right, I'm gonna go on to the next one there. Road salt, you guys want to attack it?
Swap, so you guys can point to the screen or you guys get where you are.
Yeah, nice and loud so everybody can hear you.
Very nice. Yeah.
Good job, Liam.
So road salt placed fourth overall. We had a few more issues than ISOC did with Marble Mind. It's called GPS. It's not quite GPS, it's localized positioning system. So it's similar to GPS in the sense of it has 3 stationary beacons set up around the field. And then there's 2 more mobile beacons on the actual robot itself. So those would go on the 2 upright pillars.
I can add to that. So what Alex mentioned was that the area that the snowplow would maneuver about has those 3 stationary beacons. So it creates a triangle. And then within the triangle, aboard the snowplow, we have those 2 mobile beacons. And as the snowplow maneuvers about that area of maneuver, it's using trilateration, 3 points to identify where that snowplow is. And the way that we accomplished our navigation was by establishing waypoints along the T that was the established route for the snowplow to navigate and push snow. But the sensors that we utilized this year were from a company called Marble Mind. They are located in Estonia, kind of far distance to kind of communicate, troubleshoot, but they're very receptive via chat. Ashley can attest to that.
Yeah, their troubleshooting videos leave a lot to be desired.
And
We had obstacle avoidance with our system, but we did not have obstacle detection, which you will see later in our actual run. Yeah, we did not. We were working with a brand new system this season, so we had never actually used the Marble Mines sensors before. So we spent a lot of the build time, I guess, just trying to learn how the program worked and how to program it and use it correctly.
Drive.
Yeah, it took a lot of time just to get basic navigation that we didn't have time to invest in an actual obstacle detection. Because of that, we had to hard program in an actual avoidance, which worked mostly on our second run. We did not have it at all programmed for our first run. You can go next slide.
I will say we did push snow and a few cones.
Yes. So yeah, you can see there how that would be set up in the field, kind of without you can't see the stationary beacons on this one, but you can see the 2 mobile beacons.
Are you ready to watch the video?
Yes.
All right. Here we go.
Ryan said he's not in.
Pause it real quick and see if I can let somebody in here real quick. People, there we go. I see someone now.
Ryan Cloutier at the top.
Got him.
Thank you, sir.
You're welcome, sir. All right. Make this big again and play this here. All right, you guys can narrate us however you like.
Right now it's following a pre-programmed course that we spent a lot of time dialing in. And there it is. We don't have, like I said, we don't have obstacle detection. So yeah.
We were hoping we'd be later in the lineup so we could see where the obstacle would be and pre-program, but we drew first lot. So
Yep.
so we kind of just decided to
We had
move snow and cones.
20 minutes.
Yeah.
We had 20 minutes to try to program something. We attempted to program it. It did not go well at all. So we just kind of scrapped that idea and just kind of ran with what we had.
Do you see this piece of wood vertical? Atop here on this square, that's one of these stationary beacons.
see
We
it
had
better.
3 of these posted about.
You can see it better on this one, where that sensor would be.
And mind you, those 3, what would you call them?
Station.
The actual,
Posts.
thank you, pardon, words escape me. Those 3 posts are spaced out a very specific amount.
So
We had to measure that and then bring it over to a new truck.
So they all have string coils attached to them. We only had one major issue with that is in our morning run, they got tangled, which happen more often than I would like it to, but trying to untangle a knot in, -15 is not super fun because gloves are not helpful.
Did you guys make 2 complete passes?
Yes.
I didn't remember that.
Just to make sure we got everything, including the cone.
We avoided the cone this trip.
What's cool about this is the first experience ever with this technology. This sensing technology has never been adapted to a snowplow. It's not even meant to be used outdoors.
This one was meant for indoor use at coldest of 20 degrees. So we weren't super sure if it would actually work in
Sure.
the temperatures.
This is the Estonian
Yes.
sensor technology?
Yeah.
The GPS?
Yep.
Okay.
Sure, GPS.
Sort of GPS, yeah.
No, Marble Mine does offer an industrial version of these sensors that can withstand harsher climates, so colder temps, rain, stuff like that.
You got the commercial one.
Yes.
Very-
Which worked. So road salt's whole point is new technologies. So every season we look at maybe implementing something new. I think this one, we still aren't sure like what the best way to run it is because it was a lot of experimentation and a lot of guesswork kind of. So I think with next season, I think the current plan is to stick with this for base navigation, but definitely look at something for obstacle avoidance specifically. That would be a wonderful pairing for this because as far as base navigation went, it wasn't horrible. It is incredibly precise of within 2
2
centimeters.
centimeters when you've got it all calibrated.
Yeah, which is
System really well.
it sounds great until you miss a waypoint and it has to circle back until it hits it. And if it doesn't, it just keeps spinning.
Oh, no, the spinning, PID controller was integrated into the
Yeah.
code, so that's why integral spiral, anything like that. Pretty neat. First time learning about that kind of stuff this time.
Which it fixed that issue mostly. I think that issue did come back in our second run. And we wound up not doing as well at that time just because it had missed the waypoint going on the obstacle. Went back to try to hit it again, and in that time it also ran the barrier. So
Would you guys recommend this sensor technology to a team next year?
yes.
Yeah?
Yeah,
Yeah.
a lot of potential.
With us compiling our notes of how we troubleshooted and issues on the forefront things to do in forefront to avoid issues on the back end, yes.
Yeah. Now that we have the experience we have, I definitely think if we were to use this next season and actually experiment with it a little more and figure out really how to program it right, it has a lot of potential and we can do a lot with it. Yeah, I think the only major drawback with it is the lack of obstacle detection.
It's impressive. Very, very impressive.
Nicely done on both teams. What year are you?
Second semester,
Second semester of which year?
first year.
You're freshman?
Yeah.
Okay, Liam?
Same as him.
Okay,
I'm in my final semester of my second year.
okay, so you're finishing your AS. And Daniela? Same as these two?
But Danielle's in a 4-year degree program, so she's studying computer engineering.
Yeah.
So we get to keep her for 4 years.
Excellent.
Impressive work, guys. Impressive work.
So you can go next slide, EJ.
All right, we'll go to the next slide here. All right, so I know we don't have a Snow Devil team member here, but Ashley, do you want to try it?
Sure.
All right, Ashley's pretty knowledgeable about Snow Devil, I think.
Yeah, so Snow Devil has been using the same technology for how many years now?
Probably about 14.
14?
Just watch where you're stepping. You don't want to get out tripped by that.
Yep. Thank you. Yeah, so they have a arm you can see sticking out there with a magnetic sensor on the end. And then they lay these strips, which are actually just like cord no trip things. I can't think what they're called. What you hide cords under, and then we just attach magnet strips under it. And we lay those out and essentially just follow the magnetic path that we lay out. Where if the sensor senses magnets over there, it knows steer that way. It's pretty simple, but can get a little more complicated when they're trying to get it calibrated, especially with dealing with snow getting in the way, and our parking lot's not the smoothest or most even terrain. So dealing with the fact that your sensor is going to be all different distances. Yeah, and then they can't set it up in the garage where they're starting, so they got to make sure that they drive straight out and get it lined up right away, or they're kind of lost in the dark.
I will mention, Kit's not here today, but they did make note that the previous code that was used for Snow Devil consisted about like over, how many lines of code? Like a lot,
Hundreds, yeah.
hundreds. And that this year they condensed it to about 57 lines.
Oh, good. Nicely done. That's an accomplishment.
Especially my reason, yes.
Yeah.
All right, so here's the video from the Snow Devil. You do what?
The mag strips, I thought they weren't allowed in the garage last
No, they let them in the garage. For sure this year they did, so.
I am gonna make a quick note here. In all technicalities, Snow Devils should be our most reliable and most precise team. However, they don't always make use of the magnetic strips correctly or entirely. So we do have reverse polarity sensors that can trigger the blind turns where it won't follow a strip for that. It'll just do a complete turn on its own, which does tend to be more precise and more accurate. However, in this case, despite having the ability to avoid the obstacle, they don't, because it's more programming and it's more time and it's more planning. So
They also had troubles when they were testing with the blind turns, because once again, you got to get your sensor lined up, otherwise you're
Yes.
driving blind, where they were testing some and were successful, but then when they tried testing with some snow in front of the plow, kind of messed up everything, and they didn't know what kind of force would be behind the snow when they went to do this for the
This is
actual
where you're gonna see
competition.
the detriment of the mag strips. Watch what the snow does.
Oh, yeah.
that would be the
It
benefit.
pushes the snag strip.
Yes,
Yeah.
that would definitely be a benefit of doing a blind turn, is because there's no mag strips there for the turn. It has nothing to run into. So
If you notice the
Yeah.
bottom end of that arm, you see something yellow, but what you may not notice from this distance is that it's covered by very high-tech weather protective
Plastic.
material. It's a plastic Ziploc bag. Yeah, the sensor cannot get wet. So
So the boom arm is the mag sensor with the
There's
plastic
a-
bag on it?
at the very bottom.
there's a sensor at the bottom. That the mag arm is just to get it, like preferably out of the line of fire from the snow.
Ideally, if you were to actually market this and sell it, you'd just have magnets embedded in your sidewalk or driveway,
Yeah.
but can't really do that for a competition that's held for one day.
East Western again.
Yeah,
They
so
were,
that was-
they were prominent a couple of years ago. I guess they're prominent every year.
That's our nemesis there,
Ah.
East Western.
final standings.
All right, so this year, the Dunwoody teams were, I believe, Ice Hawk got 2,500, Road Salt got 1,500, and Snow Devil got 1,000. I think that would be $6,000. Does that seem right?
And
For
the
this
team-
year, yeah.
Yes, and the team that placed third, that's the team from Canada. They're the ones that brought the design for that guard on the cloud blade.
Oh, I'm gonna make a quick note of this earlier. Because that design was so effective of the guard, yeah, I did start making a actual file and prototype of that design for all of our snowplow blades, and that is supposed to start actually being produced tomorrow, which is very nice to have.
For next year?
Yes.
Nice.
Yeah, because I want to have all the time I can to really dial that in and make it as effective as possible.
Yeah.
So, because like that was put together in what, 2
Yeah,
hours?
it was like 2 hours. I had seen their design and was like, that seems pretty good. I could probably do that.
So it was very much effective, but very jury rigged. Which isn't necessarily a bad thing. It's just, I think with more time, we can definitely make a better design of it.
There we go.
Did that bottom statement up there.
Dunwoody total winning since 2011, $50,300.
Very nice.
Oh,
Very nice.
But I think they eat about $50,000 worth of pizza every year.
See, EJ, wasn't it Laval last year though, that didn't get a chance to compete or something? Wasn't that Laval or is that?
That might have been Ottawa 2 years ago. Yeah, there was a team that didn't get a chance to compete at all last year. Or 2 years ago, I think.
I thought it was,
They couldn't get
Case
their,
Western.
they couldn't
Oh,
get
Case
it.
Western we beat Case Western last
we
year.
beat Case Western last year, but I thought Laval didn't even get to compete because they had some break on their plow.
Yeah, that's,
So they made a huge improvement.
Yeah, that might have been the case.
One of the teams almost didn't get to compete. I'm not sure if it was,
North Dakota State.
but they did wind up competing and actually they spent a lot of time working with shop and just trying to get things fixed.
Yeah, they went from not getting a run to taking sixth place, which is pretty cool.
they beat the Iota went around State University. And,
Is this true or no?
Highly
I had a
likely.
few more zeros with that number.
so how come there were no universities from Michigan or Illinois? Or, that's two prominent, technology oriented, Wisconsin. I don't see Wisconsin schools there.
So every year when we do the snowplow competition, at one point, we had 12 teams signed up.
Yeah.
University of Ottawa had to pull out. They lost a motor controller a week before the competition.
Oh,
And the lead time on the new motor controller was 3 weeks.
Yeah.
So they pulled out. The University of Wisconsin out of Madison was signed up. They just ran out of time. It was a brand new build. So they're
Oh.
passing it off to the capstone students for next year. So we'll see Wisconsin next year.
next year, that'll be good.
Yeah.
They're a tough engineering school.
They're a good engineering school. Minnesota State Mankato, which competed for many years.
Yeah.
Their faculty member that ran this capstone project has, I don't know, some sort of hiatus. I don't know if he retired or whatever,
Oh,
but, when you lose a faculty member, you tend to lose some traction with the
Yeah,
team.
yeah.
And then Milwaukee School of Engineering reached out,
MSOE. Yeah.
and they have expressed interest for next year as well.
Good.
So it always varies a little bit. Case Western, Dunwoody, NDSU, and Iowa State, those have been schools that have come pretty much every year.
You should do, I'll see if I can get a contact at Purdue.
Love to get a Purdue
Yes,
school,
it
yeah.
would be great to have something like, mechanical engineering oriented, plus they do a lot of in cybersecurity. They do some good stuff. So that'll be interesting. Pardon me?
They're gonna add a firewall to the snowplow.
Well,
No hacking in snowplows.
there,
It's
you should
somewhere
have
you're going,
security.
Yeah.
Yeah.
I wouldn't necessarily say a firewall because they're easily defeated, but
I joke around with
If it's
these
like a
guys,
real
I was
commercial
gonna,
product, then yes, definitely, that'd be very important. You would not want someone to like hijack that and create chaos around the neighborhood.
I joke around with these guys that I was gonna wear a fiducial t-shirt to the competition. Walk
move
around,
Yeah.
or bring a bag full of magnets and throw them out there while snow devils go in or something, Just kind of randomly throw them out there.
Yeah, accidentally.
Yes.
Drop.
And so I think that students realize the ISA Twin Cities chapter, we've sponsored the event for, I think, 4 years now.
4 years now.
4 years now. So, big thank you to you guys for continuing to sponsor the event. And with that, I want to open it up for questions for the team. Technical questions, cold questions, pizza questions.
Kick them off.
Go for it.
Did you get any feedback from the judges on what they perceived, what their impressions were, any suggestions that they wanted to make after the competition was done and the staff? Did you get anything from the judges at all?
Not particularly the judges, but the safety that followed the person with the RC about the course did mention something that they were part of the Dunwoody team a couple of years back, and it's mentioned a dead man switch. They mentioned it again if we are going to incorporate it. So basically, if you have the remote control and then the plow is super far away, what's the kill distance to
Yes.
just prevent the snowplow from zooming?
Runaway. Yeah. Prevent runaway.
I believe road salt is the only snowplow that has something like that in the code. The others don't, but that is on the list of things to add for next season. It's definitely a kill switch of sorts.
They do get feedback after their preliminary design review.
Or instead of kill switch, maybe fail safe.
Yes.
That might be a
That'd
better
be a better
term
word.
that you could adopt, is fail-safe. Kill switch.
Yeah, because they have an emergency stop, they have a remote emergency stop, but the question is,
If you're
the
not
remote
present.
emergency stop, you have to physically flick it. The lack of that signal.
Yeah.
It just continues driving. So if you got too far away,
Yeah.
or if your batteries died or something like that, that remote e-stop wouldn't work.
Even in a commercial use, you aren't always gonna be watching it, so it's just nice that if it gets off of it, it goes out of a certain point, that it just turns off immediately.
Oh, don't make me the lone question
So
guy.
we have some kind of handshaking and, like, I mean, how would you do such a thing of a fail safe or a kill switch? Would it be just regular handshaking of as long as we can communicate back and forth, great, but
Yeah.
you're too far away, maybe you can't communicate or the
Yeah,
communication's
that's more or
down
less
anyway.
it.
It's just like, oh, I'm gonna stop till
Yeah.
you.
Yeah, there'd have to be some logic involved, right? And some kind of constant monitoring to see if, distance it's gone, signal strength, yada, 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 yada.
A possibility for ours with a localized GPS system is, in theory, it could return to a set waypoint if that happens.
Yep.
Yep. Which is kind of a cool subject.
A default setting,
Yes,
where it would just default to and under any failed condition, it would go to the default setting.
same with
location.
if its battery's running low, it would return to a specified location.
Right.
So,
We got a couple of questions online. Seth, did you want to throw out your question?
Yeah, I have a question for the team that did triangulation for their navigation method. I wouldn't mind having an explanation on kind of the thought process on going through like local triangulation versus like a GPS system with like a booster, like a CP GPS, like RTK type system. I kind of want to know. I want to get in your heads and figure out what was going on. I don't know advantages one way or the other. I'm curious here.
And careful, he's a UW grad, so he may have connections. Oh, NSOE, that's right.
Yeah, MSOE. That'd be great to see them there next year.
Yeah, so we know that other teams have used GPS before with the local position or local beacon, or I don't know that much about it. And had a lot of trouble with it, just wasn't precise enough. What I've seen researching GPS, you can only be accurate up to like a foot or two, which isn't too great when you're trying to avoid an obstacle.
Yeah.
Rather precisely. But we want to try something along the idea of GPS, and just I think searched precision GPS. This was one of the first things that popped up. We looked at a couple of other things, but none of them piqued our interest like this. So actually how the beacons work are the stationary ones are receivers, and the two on the plow emit an ultrasonic frequency. And then we're able to trilaterate and figure out how long, well, we don't figure it out. They figure it out, how long it takes for it to travel. So you have to input different stuff like the temperature outside to get that level of accuracy. Yeah, so we were able to order them and get them within a week. Figured we'd mess around, and I had a lot of fun trying to play with it.
And Seth, did you hear that the system they have is a commercial version of something out of Estonia?
Oh, really? Okay.
Yeah, so it's unique and imported and challenging to get support from. So they
I've
did
heard
an
of similar
excellent job.
systems using like ultra wideband for like navigation inside a warehouse or something with robotic systems, but I'd never heard of something quite this way. It piqued my interest for sure.
They actually use this for warehouses. They have like anything, just the beacons posted about, and whatever little robot they have, it navigates around. It's actually pretty neat, and they can use it for drones as well, depending on how you set up the beacons.
You can put 10 beacons onto a single server. They have a lot of potential that we haven't really experimented a lot with, just because we were trying to get basic navigation down.
Sure.
So I think,
Yeah, you can cover a very large area with them because all we did was create one sub map, as they call it, and then you're able to connect those over like up to 10 sub maps, which is 5 beacons into one map, and then you can have like 20 maps into a zone.
you can cover a very, very large distance. I'm not sure if it's quite infinite, but it's,
Yeah.
So are the stationary beacons, do they have to talk to each other? Are they cabled together or wirelessly?
They use radio. All talk to a modem that we have plugged in, and that processes all the information. But our onboard computer is actually just plugged into one of the beacons because it's able to send all of the GPS related data there, and we deal with it.
little fun fact with the with it using ultrasonics and the way they communicate with each other. If you are wearing hearing aids or earbuds of any kind, it will chirp in your ear.
If you get close,
If you're close,
You're
enough.
fine.
Experience, huh?
I don't, but one of our mentors was walking by and he was very confused.
there's hearing aids and was just like, what's going on, James?
I got another question online. Ryan, did you want to go ahead?
Yeah, it's so Ryan Cloutier, adversarial engineer in this question. So I'm the guy you got to worry about. I'm the good guy. But here's my question. When we're talking about things like fail safes or kill switches, first thing I'm thinking is remote controlled snowplow, pawn shops, banks, going through walls. So my question is when we start to think about range control and definition of boundary, regardless of the method we're using, if we're using radio signal to do our exchange, my challenge and question to the students are, what type of cyber-informed engineering approach are we taking to ensure that those authorized devices are authorized? What's going to basically, in short, what's going to keep me from using my Flipper Zero to use the snowplow to flip a car? And I encourage you guys to think about that early on. I know that might seem too much when we're just still trying to figure out basic navigation, but I encourage you to take that mindset approach to the problem because it's always cheaper, easier, and faster to do security at the beginning than at the end. And I'm very impressed with the work you guys have done. And as a gray-haired man that doesn't like moving snow, I'm excited for my commercial option to arrive at a store near me soon. But I do, because of the health, life, and safety aspects, I do kind of want to kind of spur on, hopefully, a little innovation there. It may be a unique digital ID to help identify those beacons as being official versus potentially spoofed or adversarial. So again, more of a statement than a question, but is that something maybe you guys are thinking about? And if not, is that something that at least one of you could have a passion to help explore for the team?
So I haven't thought about that at all, but I do have to say all the beacons do have unique IDs already in them, because when you want to purchase additional licenses for some of the software they have, you have to get all of that information. So they are it would already have some level of security with that.
And authentication and, registration.
There's already a lot
Yeah.
to deal with just getting them registered in the software.
To get them on the submaps is more work than you think it would be.
I feel like there's a paper, security through capitalism.
Daniela, you look like you got something to say.
Well, hi, Ryan, Daniela.
Hi.
I'm just curious, can you quickly educate me on what a Flipper Zero is? Because I would probably be the person I would focus on the cybersecurity aspect. Not this semester, Snowplow competition's done, but coming up.
Absolutely. So a Flipper Zero is a controversial piece of technology that essentially is a radio hacking device. So it is able to clone things like NFC, RF232. It can do RFID, 125 hertz, kind of your basic stuff. So garage door openers, gate controllers, basic RC. Pilots don't really like them on airplanes. TSA is getting a little bit more spicy about it. but essentially it's a piece of kit that's readily available that is what I would describe as consumer friendly. So you can't see me, but if you did, I'd look old. And by that, I mean, I used to carry a suitcase full of equipment that now fits in the size of something about this cigarette lighter. And for if you're not familiar with that, because, you know, I don't think people smoke anymore, it's maybe, I don't know, 3 inches in size. So it's very concealable, very powerful. And again, it's, you know, generally available to the public.
Is it Ryan?
Yes, sir.
Tom here, and you know me, wasn't it prominent with some of the early ATM spoofing?
Absolutely. It can, if you know what you're doing, you can absolutely use it to do what's called jackpotting. Some folks actually just got caught here in Minnesota for doing that. That is, for those of you that are curious, please don't try it.
Very, very cool.
But essentially, yeah. Yes, ma'am.
What other questions? Any other questions online or in here?
Actually, do you remember what frequency that we were using for these or no? Off the top of your
We just
head.
had a bunch of different
Oh,
frequencies.
yeah.
Are they all in the kilohertz range or are they higher?
It-
Want to say kilohertz?
Yeah.
They have hertz.
Hertz, yeah, they have.
I think one of the most impressive things, you know, these guys start working on these literally, I think September was our first meetings. And
September 9th, I think.
Yeah.
September 9th was probably our kickoff meeting. And then they would meet on Mondays to talk about plan and strategy. And then on Saturdays, they pretty much gave up every Saturday for an entire, almost all of fall semester and all of January. And you guys were here during J term a lot
6
too.
days a week.
6 days a week during J term because they didn't have class.
What is J term?
J term is that there's a short term in January. It's called the January term.
Oh, okay.
Where we don't
J-term.
actually, we're not in fall semester, we're not in spring semester. They run some short little classes in there, but none of these guys actually had a class in January.
Okay.
So they would just give up their January and come in here and work every single day. So
Play. It's called playing.
Play, yes,
Yeah.
yes.
Saturdays were from 10 to 2.
You're supposed to be from 8 to 2, but no, I'm the only person that shows up at 8.
I know I was there at like 8:30 or 9 typically. I know Liam was as well.
Yeah.
So those of us that really had nothing to do on Saturdays and didn't mind getting here a little earlier,
Yeah.
didn't
Yeah.
care.
Yeah.
I know. So my time in high school with First Robotics, for those of you that are familiar with that,
My boys did it.
our Saturdays in high school went from 9 until whenever a coach kicked us out, which was typically 10 or 11 p.m.
Wow. 12-hour day, yeah.
So because we only had 6 weeks for build season and our competitions were a lot more rigorous and time consuming than these ones were, as in it would be 3-day competitions
Right.
on
Yep.
a lot tighter schedules, where instead of having 2 competitions, like 2 matches a day, we'd have upwards of 15.
Yep.
So we wanted to make sure that anything and everything we could do, we did. So
Yeah, it's testing, right?
yes.
You test as much as you can.
So I know 3 of you are first year. Ashley is gonna graduate and go on and get some really cool job doing robotics somewhere. But the 3 of you are gonna be back next year?
Yes,
Definitely?
hopefully.
Hopefully.
Are you from Minnesota, Ashley? You're gonna,
No, I'm from Nebraska.
Nebraska?
Yep.
Wow, you'll be making robotic snowplows down there, I perceive.
Oh, I'm staying here.
Oh, you're staying?
If any of your companies are looking, this is a good one that's ready for employment right now. So
So if you don't know, I'd go to Tenant, I'd check out Tenant. You know that company?
I'm not familiar.
They're TENNANT. They make autonomous floor cleaners. You'll see them at Sam's Club, a variety of other places. A lot of warehouses have them. They do.
I
Do they
say
do,
Toro. Go to Toro. I want to buy this thing.
I know an engineer who works at Toro,
Yeah.
doing similar things.
Seth, did you have a question?
Yeah, I have a couple questions actually. First one
Go for
is
it.
what first robotics team? I was for FRC. I was on 1816.
56, 53, the Iron Mosquitoes
Okay, yeah, I'm familiar with you guys.
went to nationals in 2023.
Iron mosquitoes, that's way up north, right?
Yeah, that's up in Babbitt on the Iron Range.
Whoa.
Yeah. I am not a Minnesota local. I was born and raised in California and moved up here when I was 17. Because my dad wanted to be closer to family in Grand Rapids. So
Seth, what is 1816? That's not Edina, is it?
That is Edina, unfortunately.
The green machine?
Yeah, yep. So my real question is, what are you guys using for a controller on board? And I guess each team probably has a different approach, but I'd be curious to know what that looks like.
for actual like physical remote control is. Or
He means the robot
The
control.
motor controller.
Yeah.
Robotech.
Pretty sure they all use Robotech, right? Yeah.
We're not thinking game controller here, we're thinking,
our actual
Yeah,
physical
I'm thinking like
controls are all
PLC
RC
controller.
RC airplane controllers. So yeah, remote controlling drones effectively. So
When you guys talk about the Robotech?
Sure.
Alright.
As far as I know, all of the robots have the Robotech motor controller. I don't think you can. Yeah, no, it's in there.
It's very, yeah.
It's like this big. Basically, it's the computer that controls the motors. Basically, you'll give it like digital signals from a wire, and it will rotate the motors. Basically, it has a bunch of built-in like features to it. There's like was it PID like you were saying? I think that is a feature built into these.
How about your code? Where does your code reside?
That's different depending on
Well,
which
Snow
teams.
Devil's code is in the motor controller. They use Micro Basic, and then both of our teams use an onboard mini PC that we connect and output motor controls to the motor controller, which sets them to the motors. But we use RoboRealm software and VB script for programming, and it's got all different kinds of modules and stuff. They used basically machine vision based stuff. We had a GPS reader on there that we were able to set our waypoints on.
there's a ton of different potential like options that it's all able to be implemented onto these systems. We've only played with a handful of them. I know that's kind of why we wanted to do GPS is because Ashley was looking through the capabilities on it and she saw GPS as an option and said, that sounds kind of neat. So that kind of sparked our interest with that.
So to follow up on Seth's question, I heard some PC based technology in one of them, and the other motor controller. Did you look into what forms the basis of the motor control? Is it a field programmable gate array that's customized for motor control? Is it an ARM processor that you might find in a, mobile phone? Or what other technology is part of the controller, or do you know? Did anybody investigate that at all?
I'm not there yet.
So
Not there yet?
the interesting thing with these ones is no one here had any part in the actual design of what's in them.
Adopted.
Yeah, these have been the platforms we've been using for the past, 6 years, give or take?
Yeah.
So they initially were all different, and then they standardized the parts, standardized the equipment that was in them, just to make it easier for maintenance and just flat out operation. We are looking at, because they're so old, we don't have wiring schematics of what's actually in them entirely, and they're also not super organized, so I think that's something else we're gonna do during our off-season. Is
Good plan,
definitely,
good plan.
I know Jeremy and I spent a little bit last season messing with some of the wiring in this one. And at that time, we realized just how unclear things were because half of the things in there aren't marked.
Yes.
Yeah, half that stuff isn't marked like at all. And the other half is very tangled. So it's kind of like digging through a rat's nest, trying to figure out what goes where. So that's definitely something that's gonna happen in our off season is wiring schematic and organization, so we can find things easier.
Good thinking.
You had sort of a relative description, but beacons, how far apart can they be?
Up to 30 meters
Yeah.
from each other.
Wow, okay.
Yeah.
They cover a lot of area.
We were able to cover the entire snowfield with just 3 of them, which isn't a small space. We could do more to make it more accurate and get more viewpoints and really narrow in what it's doing. But for our purposes, it's not necessary. If you were to do this in warehouse application, you would probably have 7 or 8 of them scattered around just for full coverage.
And what operating system are you running on the PCs?
Windows.
Probably Windows 11, right?
It's Windows.
Yeah.
We're not using
Definitely.
that anymore, right?
We've had a few students recommend better options, but it would be more effort than I think it's worth to fully switch them over from Windows to really anything else. Just because it's like, yes, it would be nice and it would probably run better, but for our purposes, it's really not necessary.
Yeah, especially for generational type.
Yeah.
Development.
And because it's only used in one competition for one day,
Yeah.
it's
Yeah.
more effort than it's worth at this moment to really put any effort behind that. So,
Yeah, you kind of want a generic
yeah,
computing platform and do all your design and software.
it's,
And
if
it's
we,
systems of systems, right?
if this was going to be a commercial use,
Yeah.
it probably wouldn't run Windows. You'd probably want something a little more reliable
Yeah.
and a little more streamlined. But for our uses, it's really not a problem.
I don't know if Microsoft Teams, negated what you just said about.
Oh, about Microsoft?
Yeah.
Assuming you're using a Windows PC as the controller, what's the interface between that and the hardware?
Do we know
From
that?
your Windows PC to your motor controller.
Or just,
USB
I believe it's
serial?
wired, yes.
Is it
wired
USB?
serial or something like that.
Yeah.
Wired serial.
Or, yeah, I am fairly certain.
232 or
I do not know off the top of my head.
485?
Yeah, specifications are.
Okay.
No, we got,
Really need to worry about it that much, so.
Ashley knows.
we got a handful of like questions like that from judges of like specifics and rather than not just general operation of the inner workings of it, but actual specifications.
Yes,
And
yes.
we could not answer a lot of those questions just because we don't know a lot of that stuff because
You're not there yet.
no.
Yeah.
And a lot of the information on that wasn't really well documented.
Yep.
So we have wire schematics from that time. We don't know where they are. And even if we found them, they wouldn't really be accurate because that was 6 years ago. So
And when Bob asked the question, I was playing devil's advocate, and when I said 232, I was expecting maybe Ashley say 232, 233, whatever it is. That was a line out of an old movie that is clearly.
Way older than us.
One thing I enjoyed in the poster sessions, everyone seemed to be an all hands on deck team.
Yes.
Whatever, I mean, hats off to ice hockey. It seemed like there was the two of you.
it is just two of them.
And then others were larger teams, but I bet there were challenges of just collaborating.
So
Because it's very easy, everyone's got their little part, but you have to be able to come together and share ideas and accept each other's criticisms, like, I don't know if I would do it that way, maybe you tried some other way. Was that like really easy to
so
come together, or is it kind of, you had to grow into it, the more Saturdays spent together, then it got easier?
So it depended on the team. Road Salt is the largest team we had, and the funny thing with that one is it started off as just Ashley and I. In the start, like kickoff of the season, it was just gonna be Ashley and I, and then I think by week, Daniela, you came in what, week 3 or 4?
sometime in October.
Yeah, is when Daniela came in, and then it was 3 of us, and it just kind of grew steadily from there, and it became actually our largest team with 4 consistent members. How many were actually registered to the team, Luigi?
I think if you up on your sheet, there's like 6 or 7 on your poster.
Yeah.
Yeah.
6.
So
Lost to the flame.
Yeah.
That's what it was.
The others had
just the best
2.
team.
Yeah.
People know it.
Both
But
Ice Sox,
fucking-
both Ice Sox and Snow Devils only had 2 members for their team. So theirs didn't necessarily require a whole lot of like they needed more collaboration to talk to each other, but there wasn't as much like adversary, I guess, or not necessarily adversary. It's more, there weren't as many opinions. So you could get your idea across a little easier.
I would say there was plenty of Saturdays where Liam was by himself.
There's that.
You didn't have to check in with anybody?
You could rule the world.
I just want to encourage you all because some of the best jobs I've been blessed in, and I see it in other places, other people talking with, like a lot of these people would probably back it up, that it's one of the funnest things to do in like automation or anything even remoted to snowball competitions. You can get paid to do this kind of work.
Yes.
And yes, other people have done it, but you're always going to be encountering things like no one else knows how to do it better than you're trying to struggle through. And there's a little pressure in that, but there's also freedom.
Yeah.
And we get, you can look forward a lifetime of working with other people just like you're doing now.
I think my experience at FRC with our team of 30, give or take, we had the core of it was 7, and that our 7, we had a lot more opinions, and it was a lot more definitely communication, like you're saying. That is the most important part in any of these teams, where it's you need to talk to each other, especially. So my role on the team was prototype designer, so I needed to be working with Ashley and Daniela relatively often, just to make sure that what I was doing was A, relevant, and B, actually going to be implemented and useful. For instance, the main prototype I was working on was housing units for those sensors. However, because they were ultrasonics, any form of gap in the housing unit between the outer wall and the actual sensor would cause an echo and distort its location and its ability to tri-coordinate or trilaterate, my bad, where it is. Because of that, the housing units were not actually implemented, unfortunately, because I spent a lot of time getting those right. But that's just, they worked fine without them, which is nice. But it would have been nice to actually get that correct enough to be used. But even when it was snug against the sensor, it still wasn't perfect. And there would still be that echo and that error. So
We got another online question now. Seth, if you had another question there.
Not so much a question. I was kind of going to answer something. I think it was Tom asked the question about the Robotech architecture. I don't know exactly how, and I haven't worked with them for a while now, because I think they got acquired by Nidec and some things changed. When I programmed them, they used CAN over RJ11. So they were basically like a mini PLC, like some type of conventional architecture with some specific ICs for PID handling or something like that, all contained on a little box like the size of a stack of Post-its.
Yeah, I think out of the 8 teams that were there, I think 7 of them were using the Robotech motor controllers. So they're big monsters. I think I want to say 100 amp output on these things. So they are massive. Jeremy may know more.
I think that's right.
Yeah, I think 100 amp continuous they can provide.
Something like that, yeah.
So they're big monsters. We run the control system runs at 24, but the power system runs at 48 volts.
100 amps, 48 volts.
100 amps, 48 volts. That's what those motors can do. Yeah.
we have those
That's
batteries on each robot. So
Now, mind you, hopefully we're not running at 100 amps, right? We can limit that. We don't have, but they're capable of that. So.
Do you
Is that
know
what
what
you
those
use in
motors
your
are from?
So the motors that we use they're NPC motors. I'm sorry to be taken, but they're NPC motors. They're originally designed for originally NPC got it. It would stand for National Power Chair, which was they were electric wheelchair motors. And then they started to get into military and all kinds of other stuff. But yeah, so I think the motors actually can go all the way up to 60 volts DC. But we run them the reason why we run them in 12, 24, 48 is because we're running car batteries, right? We're running, standard interstate 12 volt batteries is what we're running in these things. So
And these are specifically their high torque versions too.
yeah, high torque, big gearboxes on those motors.
So that's your Baja power plant too?
No, Baja's gas.
Oh, it is?
Yeah,
Oh.
Baja's gas. Shell Eco Marathon is electric, but that's a totally different animal altogether. So
we did have one motor failure in Snow Devils. And the annoying part with that one is because these motors are 6 years old, give or take. They didn't make that specific motor anymore, so we had to redesign the actual motor mounting plate for it, which we are looking at doing for all of them because they were all installed. They were all installed at relatively the same time.
Yep.
So when one motor starts failing, they all start failing soon.
Yes.
So
You're picking up some good experience with this kind of electromechanical project, as they say in Canada. So that's excellent. Yeah, that's very, very excellent.
Well, if there
Nice
are,
job.
yeah, good job. We'll give you guys a round of applause. You guys are welcome to stick around and talk to these guys or come see the robots or eat more food that's back there. But I'm gonna stop the recording and this will conclude the Tech Talk of February for the ISA.
Yeah.
Thanks, folks.
Good job, EJ. Good job, guys. Thanks for your help.
Thanks, guys. Appreciate the presentation.
Thanks, Seth. Eat the sandwiches.
Yeah. I'll come up with more questions, I'm sure.
Absolutely. Grab a sandwich. We wants to test drive one. We can put them on RC control. You can drive them around the room.
still safe.
I was being serious.
But I prefer the.
I'm a little surprised that Ryan didn't ask
Six.
whether you would want to.
That's a PC right there.
I saw you earlier and I just wanted to come over and say, hey.
It's just a little bit PC. You can get PCs now.
What's going on?
The size of it don't work right now.
At my 6900, no.
Yeah. The size of it don't work.
69.
These are a little
September.
This on one, they're nice.
You got all the things that.
You got all the connections and they're capable of going down to like,
Hey, that's
0
really
degrees Fahrenheit. But
It's,
a little weird sometimes. Different. Well, this is
Yeah,
our
yeah.
stop. This actually.
Nobody knows,
Actually,
really,
really.
unless I tell them.
These are 150.
150 amp.
Yeah.
I knew there were a lot.
They're
Yeah, they just say 150 amp max, 80 amp.
Are you still teaching too?
I didn't teach this year. Still employed by mid-March. I think they said next fall I'll be teaching. They didn't have the enrollment this year for online students.
Really?
So they're also doing some moving and shaking because they've historically it's been a 2-year instrumentation control program. That's what I went to school for.
Yeah.
But they're gonna roll it into like an instrument and electrical program. So your first year is gonna be electrical, motors,
Like freshmen, you guys.
second year, they're kind of juggling.
Both with all, that was awesome.
BSE. So it's interesting because like when I went through school and what I teach, it's all process instrumentation.
Yeah,
Nothing
that
like
is
this.
worth
Like, we never touched, I mean, we did PLC, motors, motor controls. We never did
Enjoy
anything
it.
like servo
Nice thing, and
motors.
it's like
back and send back
About the
to the-
beacons and sensors and stuff.
Yeah.
Totally different than what I used to.
Of course.
That's when I retired.
And it's another 5
I don't know if I said it. The
The
other lady.
You know, when I
Yeah,
was
the
talking
other
earlier,
lady.
I noticed you, and then it.
Are you familiar with the FRC at all or not? The first robotics. Good place to go.
Into.
So I am familiar with it.
Yeah.
Before I saw his email about.
A newer section of the FRC and we're gonna get up limelight.
And it's talking to the former district.
The new one, so I was also
The elect. For like 5 years. He was so busy. at work.
one of the other things that
I stepped in and did the VP.
I'm looking at using it on ours.
So when
Scott season, I stepped in and the goal in action. I know it's one I know it's my. But that sounds like.
I can remember that.
Yeah, I.
Yeah,
I do it at my
Yeah,
leisure,
right.
my convenience, my bandwidth.
I don't know what
Maybe you're
companies
on
work
Zipcar,
with
so I say,
recruiter and they don't just.
Right, so
Sounds like
I'm turning my resignation.
I just want to make sure my snowplow.
That's
That's
good, but.
I go and make
Did they say anything else?
In a real house,
Knows Miller
Like I said, I can think of 2 different companies actually,
As
Siemens and or Trump. They make,
And
well, they make a lot
I
of, but
thought
they
he
keep marketing.
Emerson.
Trump makes a lot of future stuff.
I was gonna say, yeah.
Yeah.
Emerson.
They.
And he was suggesting that
maybe one of the things we
They
could do is
want
get
the
one of the
PLC
education ventures.
program.
To give us a celebration.
Oh. Let's talk about.
They have like
Yeah, so-
the code and stuff that's in German. They need to translate and integrate.
It's not
Used equipment.
That's the thing, so
Yeah.
I don't have any equipment, and Bismarck State, they've asked me for years, hey, can we get old pneumatics? They were, throw all the, throw that stuff away all the time.
Yeah.
You donate to the program, they refuse. It's like control or donate or anything else. That's been used, that's been used in service.
See, you would hope it's that easy.
Well, I think what
The first job I ever,
is if you talk to some of your folks, your management.
First
and
job I ever did.
Even corporate legal.
the first automation
I'm
project I ever
working
did
at
was,
institution.
rewiring
We're not
laser
using
cabinet.
it. in
when
the
all the
light
schematics
of-
were-
Products, right, yeah, we're not using, yeah.
We're
That was
using
during my
it.
first semester and I had to figure it out.
Yeah, I've inquired about donating our pneumatic belt conditioners to
Yeah.
our safety.
Way back in the day.
Way back, in the day, just way back.
Yeah, and it's still in the field.
Yeah, we still
Like
have it in the
5, 6,
field.
5 years ago.
Stuff you guys were even all the time, that's, we upgrade to electronics.
They're not there yet. So.
That's been in service. They worry about someone getting.
Yeah, oh yeah, I was in there after when they started, 2018.
Somebody has a
The
reaction.
2018 competition.
So they're like.
Huh?
Well,
It's frustrating. It's kind of like the. Yes, me at the refinery too. Oh, I want to, I get to it.
Back when my hair wasn't gray,
Kind of like the nuclear plants, right?
no,
Less gray at least.
my oldest son has
Here's to a nuclear plant.
he's working in 3 hours.
Oh, he is.
And because he was in the Navy, and he's
Yeah, you do the Navy new.
Navy new, and now he's got his NRC operations instructor. He doesn't have a license yet. And he's a jury.
That's like SRO, and we're a licensed operator. Is he in the instructing side of things?
Yes.
Like training?
Yes.
That was a, no.
But I don't know what's doing the planning and
Like, here's a line.
strategic.
Well, where they were in the city too, was like a little wind tunnel.
No, it's actually part of what you call the Dominions.
Yeah, there was a little wind tunnel there. It was,
And it's near the social.
no, we literally
he
froze the
knows.
board. A control board, white
Went for a
literally.
summer session, but he didn't get to take it up and go to an out. He went in anyway and became a Navy.
Yeah,
navigator.
we got some branch.
And now he's got his
Had its own.
So we get there, pretty much there, we had to get
operation.
lifted up. It was like a-
Loved Alan.
You should forget about this until the day. I have to then he arranged a tour of Texas. I said today. From the U. And I told him, I said, I'm gonna set one up for my IFA.
Oh, Andrew, yeah.
What'd he say?
And he said, yeah, I can do that.
Oh, really?
And I just talked to him the other day and I said, he's now, how many months to do it?
30 days, ID, name, all that, that run everything.
Yeah.
and-
Yep. And so now I'm gonna put that out.
On 394 to.
I'm trying to work with him to find out, would they be okay? You know,
He'll be on the way
better,
back.
people have 31 days, we all have,
They have their own like actual navigation software. I could not figure it out.
Don't kids, no.
Drop points based on like that.
So,
Well, I'll let you go.
Yeah, interesting, some of the emergency have been for 6-7 years.
Dabbling, yeah.
And we train with Excel, their emergency responders from Prairie Island.
Yeah.
And it's funny, they always have to come to our site. We ask, you love going to theirs, no. We,
I can remember.
it's easier for us to get in,
Yeah.
rather than get all of you
1 year ago.
into a nuclear
Yeah.
facility.
You would take like a little kid and they did like something, and tell you how you
they were showing,
and the
well, they
robot
were demonstrating
As long as it
some
wasn't
reactions in the
Like,
simulator.
he were the types of people watch
Simulation.
about Troy. I don't know how they were.
Yeah, that was a simulator of like.
All simulator.
Yeah.
Like a hide and seek robot.
We were walking around the plant, now they had part of, unit one, who was able, they were doing some.
That was really cool.
Yeah, they used to, your PDR. Points down your PDR presentation.
That was the,
And of course, they had.
They used to go to the final presentation, the night before the competition.
Huge.
We do the poster presentations.
And,
Those are called at the site. Some pictures, but that's what they used to do.
So I'm gonna
do the
just
competition.
trying to figure out.
And right here. However, I wouldn't go back to that.
it was really cool, but yeah,
Hey, it's expensive and people, that's getting married in here. August. Oh, man. Well, even there's no place to go get one, say, install that too, yeah.
That was the other thing, is we couldn't
Here's nose and
Oh.
throat, which now she's gonna focus in.
anything from the previous year.
Somebody can start bringing covered trailer through that, everything, Michigan had a covered trailer through that. That's right, for that big, that gas barn on your property, they brought it.
Lived in this.
That,
They live at, Territory Road and
Mhm.
280.
Gotta figure something would be a good
It's
addition.
not always, which not too far from Sterling.
Yeah.
Sure, sure.
Down 280 tonight.
They were all in, talking about, yeah, and then like, I'm emailing, I need they're on the list every week and they never got to do it.
I've never written Tesla, but
Yeah.
this
Yeah. Really people are charged there, they have charged phone. Really?
I've talked
They're gonna throw it
Yeah.
to the.
yeah, those, yeah.
And if they managed to do that, it would, he can do paperwork through school within like a 5-second pipeline. They're like a month site.
I think we should get a southern school like,
Yeah.
University of Central Florida, or UCLA operations with.
Struggle up, yeah.
I don't know.
They don't even go outside.
There
Structure,
might be some schools in Texas after the.
preparation.
that
Yeah,
we
Texas
over-
taking it out.
Yeah, they might actually be interested.
Using some,
Because
like
what
a soft, smart app.
speaker was, is
I had
we're gonna
not
shoot
heard
a disc
I haven't heard that.
into a.
And it's, I said, are you talking Copilot? Their chat GPT? He goes, no, I've used some of that, but it's not what I'm talking about.
Once I get
And he
that.
said, no, it's smart app.
Is effectively what this robot does, just a lot
Oh, that's
differently.
friend,
girlfriend.
I gotta go to Shepherd, I'm getting a for one of these marathons.
It's laser guided.
But once I get back, just call me.
I was actually looking
Whatever you
at
guys want to-
for our robots.
Nurse.
Because I know that.
The-
I know financial stuff, it is insurance.
About 5 weeks away.
I'm just not sure how, because it's not like.
Yeah, just right after.
Right on our snowplows, clients, and they're also doing some insurance, so.
Yeah.
I think
Right after you guys
that
leave.
we.
Yeah, people.
And then she
keep
tries to
asking
instruct
and I'm like,
other nurses. You have to know.
I don't have any classes.
Like this.
Start
So-
to-
What it can do. And is it an actual?
I'll get stuck in a capstone project. It'll sap your sanity.
Oh, yeah, you do not wanna do that.
Oh,
That's-
that PSA partner still annoys me.
A lot of times, some of the
What is
things.
We had this donated machine.
Oh,
That he decided to dig into, and he was literally. Oh, yeah, so he's up with the board working on it,
So
like,
he's,
working on it.
told me that
When my son was in here,
within.
he's like, who's that guy that's always working on that conveyor belt machine down there?
Oh,
That's Jeremy.
There's a couple of guys.
I had to, it was a PLC, it was a corner PLC,
They should do the instruction.
and
Only.
you had a whole bunch of servos that it was driving,
So he did.
except servos supposed to throw them. I didn't know that.
Sean.
But it's causing issues.
And Rob Benz, the dean of computer engineering at the time, taught me how to hack.
They recommend.
Great. But,
45 years.
so I had to, I started the PLC, forced to be,
That way you're not.
because I figured I could be engineer PLC, because that was not that bad. I did not realize just that some of it dump all the code in, all the.
What's the name of that grant?
As well.
While he was on
That
deployment.
was entirely different language, and I had no idea what it was. I was trying to learn it, trying to figure out bits and pieces, and
You finished your degree in
never been, you know.
computer power engineering technology, so it's a applied science
Still
program.
have all the prints and everything for that box we're gonna do it.
Thomas Edison University, New Jersey. A lot of names you doctor for your degrees there. And then.
Correct.
applied
They were very, there was,
Masters
I think somebody had done a
engineering.
Can I drive one?
print layout of all the components in the cabinet at one point, and that was about it. Yeah. That was very, very little documentation.
Nice stuff.
Colorado, the director, his boss, met him there.
You could say that. It
Oh, it was.
was definitely more than I had anticipated.
Grant, beers and a bird.
There you go.
He says, let's go.
Trade show.
And now they're buddies.
Guys, I'm driving.
Yeah, you may wanna watch it. He didn't have a ton of documentation to begin with,
Don't run over my shoes.
but then whatever we had was even less than that.
Are probably the ones you don't want them to because they
He's,
don't.
he's, my age when I was,
They will not.
data government systems.
There.
On the mission computer for the F-18 fighter.
Top left,
When I was-
road salt, back left.
I was here. That's the I was 27. I was
This one is
out of that
continuation contractors pulled in, so supply and power down the
project engineer for a radar.
Now that
process.
pops out there.
So he's in a similar
Pops out
career
there.
advancement.
Yeah. You should only have, it should be your tiniest little bit of that, the left, right, and straight, your tiniest masters.
So.
Pushing forward.
Each area.
Yeah, I thought it was set up.
No kids.
Make a cup of coffee.
You know,
And just drive on my driveway and push snow around. It's like a video game. Right.
Or, because there's an aspect of it that is safety.
So 3 batteries, what's the run time?
What's that?
How long will one of these run? 3 batteries?
So we would charge them every night, but like,
They
they
don't,
would,
they don't just die on you when you're
Yeah,
out
they-
testing? Okay.
yeah, they tend to last quite a long time. Because even when we go out and test, we don't test for more than 20, 30 minutes at a time.
What time the bridge construction is happening.
Yeah.
That was tomorrow, that's right.
But some of the spots that got over in.
Yeah, it might be.
This was one of the most important parts, trying to find a big contactor, you know, to run that, you know, because you could get 60, 70, 80 amps of current through this thing from the motor controller there.
They're not.
And so this just, you have to physically.
Not
show them that you can stop, physically cut it off, right? It does that,
So it's like, as far as.
pulls in, but I can cut it here,
Yes.
and it
They're
comes
not
out,
light machines.
or I can cut it there.
Pushing.
You see it come out on contact. Either one of those.
Yeah, it's like, no, weights on them as well, but how, for competition, that's.
Yeah.
Right?
No,
Yeah, that's kind of, that's how it creates, so that was the service, that's a
so they're.
$350 contactor.
Yeah.
Well, that's just because it's got the little blue.
Yeah. And it's 24 volt DC coil on it too.
Oh, yeah.
So we can run it off of our control system here, you know.
150.
Copper in there.
And then we add an additional 150 pounds onto it.
Yeah,
And the side weights that mount on the sidebars.
Get out of range, does this thing drop off?
So that's what I mean. It's not a, it's, there is no dead man. You know, I'm thinking like an active safety versus passive safety, right? Yep, the only way to take it away is that, right? So if you're out of range, it's still putting the signal there, right? Just wait for this to go.
It's alive.
Make that go away.
It's alive.
Yeah.
Kind of have.
That's the problem. Thankfully, we're never more than about, you know, 50 feet away from it, but they're gonna make that a rule, I think, next year, that you're gonna have to show that,
We had our.
like, when you do this. And I think there's a final thing, like, right now, your contactor's pulled in, so theoretically, I don't know if Alex is right. When Alex says that, Russell says it's on. So if that's the case, then if I turn this off, right now it's engaged, right? If I turn this off, theoretically, that should release the contactor, right? So it's shutting down, still on.
I worked with.
So the battery's going dead on this, or being a million miles away, it's still on.
Yeah, this little guy isn't, it's only operating at state of change.
Got it.
So
Looking
what's
for
this-
an actual.
What's this controller from?
Yeah,
Standard RC control.
yeah, they fly like planes and helicopters and stuff.
But what about the helicopters or drones?
Yeah. Crane's using those for drones.
Working when they.
Yeah,
do work.
Like, for instance,
Yeah, drones will pin themselves now, the smart ones will